Some basic concepts of chemistry, chapter 1 revision, importance of chemistry. Just read it. In agriculture and food, in health and sanitation, saving the environment, application in industry, matter. Matter. Anything which has mass and occupies a space is called matter. Example, book, pencil, water, air are composed of matter, as we know that they have mass and they occupy a space. There are two ways of classifying the matter: physical and chemical classification. Physical classification. Matter can exist in three physical states: solid, liquid, gas. Solids. Particles are held very close to each other in an orderly fashion, and there is not much freedom of movement. Characteristic of solids: solid have definite volume and definite shape. Liquids. In liquids, the particles are close to each other but can move around. Characteristics of liquids: liquids have definite volume but not definite shape. Gases. In gases, the particles are far apart as compared to those present in solid or liquid states. Their movement is easy and fast. Characteristic of gas: gases have neither definite volume nor definite shape. They completely occupy the container in which they are placed. So in liquids, we can say liquids occupy the shape of the container. Chemical classification. Based upon the composition, matter can be divided into two main types: pure and mixture substance. Pure substances. A pure substance may be defined as a single substance or matter which cannot be separated by simple physical methods. Pure substances can be further classified as elements and compounds. An element consists of only one type of particles. These particles may be atoms or molecules. For example, sodium, copper, silver, hydrogen, oxygen, etc. They all contain one type of atoms. However, atoms of different elements are different in nature. Some elements, such as sodium or copper, contain single atoms held together as their constituent particles. Just read it. Compounds. It may be defined as a pure substance containing two or more elements combined together in a fixed proportion by weight and can be decomposed into the elements by suitable into their constituent elements by suitable chemical method. Moreover, properties of a compound are altogether different from constituting elements. These compounds have been classified into two types: inorganic and organic compounds. Okay. Mixture. Combination of two or more elements or compounds which are not chemically combined together and may also be present in any proportion is called mixture. Example: milk, sea water, petrol, lime water, paint, glass, cement, wood, etc. Okay. Types of mixtures. Mixture are of two types: homogeneous mixture and heterogeneous. Mixture is said to be homogeneous if it has a uniform composition throughout and there are no visible boundaries of separation between the constituents. A mixture of sugar solution and water has same sugar water composition throughout and all portions have the same sweetness. Heterogeneous mixture. A mixture is said to be heterogeneous if it doesn't have uniform composition throughout and has visible boundaries of separation between the various constituents. Different constituents of a heterogeneous mixture can be even seen with naked eye. Example: iron fillings and sulfur powder are mixed together. Difference between compound and mixture. In a compound, two or more elements are combined chemically. In a compound, the elements are present in the fixed ratio by mass. This ratio cannot be changed. Compounds are always homogeneous, that is, they have the same composition throughout. In a compound, constituents cannot be separated by physical methods. In a compound, constituents lose their identities, that is, compound doesn't show the characteristic of constituting elements. Mixture. In a mixture, one or more elements or compounds are simply mixed and not combined chemically. In a mixture, constituents are not present in fixed ratio. It can vary. Mixture can be either homogeneous or heterogeneous in nature. Constituents of mixtures can be separated by physical method. In a mixture, the constituents do not lose their identities, that is, a mixture shows the characteristics of all the constituents. This is a flow chart of it. Properties of matter and their measurements. Fundamental units and quantities you have already read in physics, so I'm not reading. This also: length, meter, mass, kg, time, second, electric current, ampere, thermodynamic temperature, ampere. Sorry, electric current is ampere, thermodynamic temperature is Kelvin, amount of substance mole, luminous intensity candela. If you want to read this, then read. I'm not interested in this is mass and weight. Mass of a substance is the amount of matter present in it. Mass of a substance is constant and can be determined accurately in laboratory by using analytical balance. SI unit of mass is kilogram. Weight: it is the force exerted by gravity on an object. Weight of substance may vary from one place to another due to change in gravity. Volume means the space occupied by matter. Density. Density of a substance is its amount of mass per unit volume. So SI unit of density is kg per meter cube. Uncertainty in measurement. All scientific measurement involves certain degree of error or uncertainty. Errors which arise depend upon two factors: skill and accuracy of worker, limitation of measuring instruments. Scientific notation. It is an exponential notation in which any number can be represented in the form n into 10 to the power n, where n is an exponent having positive or negative value, and n can vary from 1 to 10. Thus, significant figures are meaningful digits which are known with certainty. There are certain rules. Often while calculating, there is a need to convert units from one system to other. The method used to accomplish this is called factor label method or unit factor method or dimensional analysis. Laws of chemical combination. This is important. A combination of elements to form compounds is governed by following 5 basic laws. First, law of conservation of mass. This law was established by a French chemist, Antoine Lavoisier. The law states that in all physical and chemical changes, the total mass of the reactants is equal to that of the product. In other words, mass can neither be created nor destroyed. Law of definite proportions. According to this law, a pure chemical compound always consists of the same elements combined together in a fixed proportion by weight. Means, a pure chemical compound always consists of the same elements combined together in a fixed proportion by weight. मतलब जो एक प्योर केमिकल कंपाउंड है हमेशा उन सेम एलिमेंट्स से बनकर बनेगा और उनका जो प्रोपोर्शन है वो वेट का फिक्स्ड होगा. अच्छा, जो भी केमिकल कंपाउंड बनेंगे तो उनके एलिमेंट्स का जितना भी वेट है उसका और जो प्रोडक्ट निकलेगा उसका दोनों का जो प्रोपोर्शन है वो फिक्स है, कांस्टेंट है. वेट चेंज नहीं होगा. सिंपल सी बात है, बस लैंग्वेज थोड़ी डरावनी है. pure chemical compound always consists of the same elements combined together in a fixed proportion by weight. For example, carbon dioxide may be formed in a number of ways: by burning coke in air, decomposition of limestone on heating, and action of dilute HCl on washing soda. CO2 and oxygen are in the ratio 3 by 8 by weight. Law of multiple proportions. If two elements combine Law of multiple proportions. If two elements combine to form two or more compounds, the weight of one of the elements which combine with a fixed weight of the other in these compounds bears simple whole number ratio y by weight. Two elements combine to form two or more compounds. The weight of one of elements which combine with the fixed weight of other in these compounds bear simple whole number ratio y by weight. Hence mass of oxygen which combined with fixed mass of bear a simple ratio. Mhm. एक बार और रिवाइज करना Gay-Lussac's law of gaseous volume. The law states that under similar conditions of temperature and pressure, whenever gases combine, they do so in volume, which bear simple whole number ratio with each other and also with gaseous products. Avogadro's law. Avogadro proposed that equal volumes of gases at same temperature and pressure should contain equal number of molecules. If we consider the reaction of hydrogen and oxygen to produce water, we can see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed matter consists of indivisible atoms. All atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon, taken as 12. It may be noted that atomic masses as obtained above are the relative atomic masses. One atomic mass unit is equal to 1/12 of the mass of an atom. C12 isotope. It is also known as unified mass. Average atomic mass. Molecular mass is sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by number of its atoms and adding them together. Formula mass. Ionic compounds such as NaCl, KNO3, Na2CO3, etc. do not consist of molecules, that is, single entities, but exist as ions closely packed together in 3D time space. In such cases, the formula is used to calculate formula mass instead of molecular mass. Formula mass. Mole concept. It is found that 1 gram atom of any element contains the same number of atoms, and 1 gram molecule of any substance contains the same number of molecules. This number has been experimentally determined and found to be equal to 6.022137 into 10 to the power 23 or 22. The value is generally called Avogadro's number or Avogadro's constant. It is usually represented by Na 6.022 to the power 23 or 22. Percentage composition. Mass percentage of an element is mass of element in the compound into 100 by molar mass of compound. Empirical formula. Formula of the compound which gives the simplest whole number ratio of the atoms of various elements present in one molecule of compound. Molecular formula. Formula of a compound which gives the actual ratio of the atoms of various elements present in one molecule of the compound. Stoichiometry and stoichiometric calculation. Limiting reagent and reactant. Mass percent mole fraction. Mole fraction is the ratio of number of moles of a particular component of total number of moles of solution. Molarity is defined as the number of moles of solute in 1 liter of solute. Number of moles of solute in 1 liter of solution. Molarity is equal to number of moles of solute by volume of solution in liter into 100. Molality is defined as number of moles of solute present in 1 kg of solvent. It is denoted by small m. Molality is equal to number of moles of solute by mass of solvent in kg. Maybe it's into 100 ho. Quantitative study of reactants required for product form is called